Hello. I did not see the video start. Hey y'all. Let's go ahead and keep doing what we were doing. Where did it go? Right there. Okay. So we found the GCF of those terms up there. Now we're going to actually apply what we know and learn some new stuff. So divide the following. It says find the GCF, pull the GCF, use the quotient rule. It's supposed to say and cancel common factors. And cancel common factors. There might just be one, so let's do parentheses if possible. So let's do this. Okay, the first thing we need to do is find the GCF. So I'm actually going to come over here to the bottom left, and we're going to find the GCF of, actually, I don't believe we need to do the prime factorization for this one. If you look at 24 x to the fourth, and you look at a negative 8x cubed, just look at the coefficients. The largest number that will divide 24 and 8 is going to be 8. And then for the variables, the smallest exponent is, sorry, I was going to say is cubed, but I was trying to not say that. The smallest variable is x cubed. So this is what I mean. We found the GCF, right? We're going to pull out the GCF. Okay, and the way you do that is we're going to write it 8x cubed. And then we have 4x right here. Okay, so I pulled out the 8x cubed, right? This is the same thing that we've done with the quotient rule, but now it's just kind of written a little different. I'm going to do my parenthesis. We're going to use the quotient rule, and this is what I mean by that. What we're going to do is 24 x to the fourth, that's this first term. You're going to divide it by the GCF, divided by 8x cubed. 24 divided by 8 is 3. X cubed divided by x to the third is keep and subtract your exponents. So I just get 3x. Your quotient goes right there. Now let's do negative 8x cubed divided by our GCF, which is 8x cubed. 8 divided by 8 is 1. X cubed divided by x cubed, well, you would keep and you would subtract, right? That's, here, let's just do it. 8 divided by 8 is 1. Signs are different, so it's negative. Keep and subtract, we get x to the 0. Doesn't that just go to 1? Negative 1 times 1 is negative 1. Close your parentheses. We started with 2 terms, so after we divide, we should still have 2 terms, okay? That's why you do need to have the 1 there. I always talk about that little 1 that we never really have to see that often, but this one's like a placeholder. We have to have it. So now what we would do is let's look at our 8x cubed in the numerator and the 4x in the denominator. Let's see if those can be reduced any or if it can be divided. So come right here, 8x cubed divided by 4x. 8 divided by 2 is, I'm sorry, see, I knew where I was going. 8 divided by 4 is 2. Signs are the same, so it's positive. X cubed divided by x is keep and subtract. So in my numerator, I have 2x squared. And then in parentheses, I still have 3x minus 1. Do you notice how I no longer have anything in my denominator? So I actually don't need that fraction bar. There we go. What I notice here is the same thing we did in the previous videos where I have a monomial times a binomial. And what you do is we're just going to distribute it into the parentheses. 2 times 3 is 6. Because we're multiplying, you keep and add. And then 2 times 1 is 2. Signs are different, so it's negative. X squared times no x squared is still just x squared. That's the final answer, and that would be the quotient to dividing that polynomial by that monomial. So a whole bunch of just little different things going on there, okay? But if you notice, it's using a bunch of the stuff that we've learned up until now, okay? So let's do this one. This one we are going to do prime factorization because we do have three numbers. What is my dog doing? She's acting very weird. I don't know. Like she sees like a little fly buggy or something and she's like trying to catch it. Okay, so let's go ahead and individually, we're going to find what the GCF is of these terms. If you don't see it, I think once we say what it is, you'll then see it. Let's just go ahead and do it. So if we do prime factorization, oh, hold on, you know what? 42, 24, and 30, y'all. We did this in the last video. 42, 24, and 30. We did the prime factorization of 42, prime factorization of 24, prime factorization of 30, and we got that their greatest common factor was 6. I knew that looked familiar. So I already have, y'all are going to need to go to bed soon. So that means stop eating, stop walking around, no more going outside, okay? Seriously, I can't afford to feed y'all snacks every 5 minutes, boys. Okay, so the GCF for all of those terms in that numerator is 6. And now what we need to do is look at our variables. The GCF for variables is going to be the one with the smallest exponent. So we know 6 is the GCF of the coefficients. And then what is that variable that has the smallest exponent? Yeah, it would just be x, right? I'm going to write it in this form because that's how it is. You do your parenthesis, like start it, open it, because what we're going to do is take each term and divide it by the greatest common factor. So we have 42x to the 6th divided by our GCF, which is 6x. If you do 42 divided by 6, you get 7. X to the 6th divided by x is keep and subtract because we're dividing. This quotient goes right here. Now let's do our other term. We have a negative 24 x to the 5th divided by our GCF, which is 6x. And what we get here is 24 divided by 6 is 4. Signs are different, so it's negative. X to the 5th divided by x is keep and subtract. That negative 4x to the 4th goes right there. And then we have a 30x divided by 6x. 30 divided by 6 is 5. X divided by x, you keep your x, subtract your exponents, you get x to the 0. But anything to the 0 is just 1, right? So you could just kind of mark them out. I'm able to do that because it's all multiplication. There's no plus or minuses there, right? It's like in between them. So I just get 5. Positive 5 goes right there. Okay, so now if you look at the directions, it was find a GCF, pull the GCF. That's what we did, right? That's the actual dividing part. So let's pull that GCF out of each term. Use the quotient rule. That's what we're doing whenever we're pulling a GCF out. Then it says, and cancel common factors if possible. Because up top is not what I wanted to do. Because up top, it's this 6x times that set of parentheses, that's multiplication. And then at the bottom, all I have is 6 times x, that's multiplication. Because that's what's going on in this problem, I actually can cancel these factors. Now, if you just have something like this is a random little side note. 6x minus 2x3 over 6x. You cannot do this. The reason why we cannot do that is because of that sign right there. Okay, that's why we're doing what we're doing. Because once we finished with our problem, now that's multiplication happening in the numerator. When there's multiplication, you can cancel like common factors and stuff. But when you have anything like this going on, you cannot just cancel. You have to see, oh, is there a GCF? Let me pull it out. Oh, okay, now can something cancel? Okay, that's your That's your train of thought there. So what's left, y'all? Just 7x to the 5th, a negative 4x to the 4th, and a positive 5. That is the quotient when 42x to the 6th minus 24x to the 5th plus 30x is divided by 6x. Okay, so I'm going to stop this video. We will come back to look at this one because there's just like a special little something that you do whenever your leading term, your leading coefficient, right, your first number, your first coefficient has a negative sign, and we're looking at pulling out a GCF. Okay, and then after that, we'll do this word problem right here. Word problem, that sounds funny. Like, it doesn't look like the other problems. It's just a question actually written as a sentence. I'm going to show you how to solve that one as well. So make sure if y'all have any questions, what happened? Make sure if y'all have any questions, y'all ask, okay? Thanks. Bye.